In this lesson, we're talking about more multiplication properties of exponents, okay? And what we're looking at this time is what happens when you raise a power to another power. So, for example, 4 to the third power raised to the second power, right? So this is raising a power to a power, okay? So what happens is, what you'll do is, you say, well, 4, and you'll multiply the two exponents. So in this case, it's 3 times 2 is 6, okay? And down here, it works the same way with variables. So x to the second power raised to the third, it's going to equal x to the 2 times 3, which is 6, right? X to the 6. You might also ask, well, what happens when the power has multiple numbers or variables in it? Well, what will happen is that 4 will go to each value in the parentheses. Okay, right? So we did 4 times, well, 3, it would be 3 to the first power. 4 times 1 is 4, right? And then we did 4 times 2, since that's the second power, and we got 8, right? 2 times 4 is 8. So let's look at a few examples for this. For number 1, right, we see this 2, that 2 needs to go to that 2 also. So it's 5, 2 times 2 is 4. Over here, this one is starting to add in rules we've learned in previous lessons. So, well, first of all, let's do what we're learning this lesson. That 4 comes over to that 2. Well, 2 times 4 is 8. So it's going to be b minus 9 multiplied by b to the 8th. So, now, we need to remember the rules we learned first when working with multiplication properties of exponents. And that's when we have the similar bases here, right? We have the same bases. What we are going to do is we are going to add the exponents. So we're going to get b minus 9 plus 8. Well, that's going to get us b to the negative first power. Now, a lot of times what they want us to do is to simplify without negative exponents. So if they wanted us to do that, we would have to remember the rules we learned when discussing negative exponents, and that's that if it's b to some negative power, what it really is you can move that from the numerator to the denominator and make the exponent positive, so it would be b to the first power. I don't need to write b to the first power. So this would be our simplest answer for this. Check what they're looking for in your rules or in your directions. If they want it to be simplified, they'll usually want it without negative exponents. Now, next, we have an example where we have scientific notation using exponents. Okay, so that 2 needs to be going to that 6 and to the 10 to the 12th power. Well, so that 2 comes out and it goes to 6 to the second power. Well, in this case, since we're working with scientific notation, we will multiply it out. 6 to the second power is 36 times by 10. Well, 2 times 12 is 24. Now, we have to look at this and say, is this in scientific notation? The answer is no, it is not, because this number here needs to be between 1 and 10. It could equal 1, it cannot equal 10. And this is greater than 10, so it does not work. So I would need to move this decimal over, right? There's no decimal, so it always starts there, so I'd have to move it over 1. So it needs to be 3.6 times by, well, let's pretend we ignore this for right now. If we're not quite sure, we're still learning with scientific notation. And we'd say, if it was 36, I'd write 10 to the first power, right? Because 3.6 times 10 is going to equal 36. But since we have it times 10 to the 24th power, okay, we need to make sure we have that. And then we just add. We use, well, it's the same base, right? This is raised to the first power, this is to the 24th. So we need to do 1 plus 24 is 10 to the 25th. It's 3.6 times 10 to the 25th. Say, well, is 3.6 between 1 and 10? Yes, it is. So we're good. That is the answer. For number 4, this one's a big problem. There's a lot going on. We're going to combine a lot of the rules we've learned. So, let's take care of this first side. Alright, this first one here. So 3 to the third power, right? 3 to the third power. This is going to be 4 times 3, so it's going to be f to the 12th power. This is g to the negative third times by 3, so 3 times negative 3. That's going to be to the negative 9th power, right? A negative times a positive is a negative. Over here, I get 2 times negative 8. Well, 2 times negative 8, 2 times negative 4 is negative 8. And then from there, since all that's left is this is just multiplication, so I can use the associative property of multiplication, the commutative property of multiplication, and I can rearrange this as I need. So I could rearrange this problem. Third, I could rearrange it to have f to the 12th, f to the negative 8th, g to the negative 9th if I wanted, so I can see those right next to each other. But basically we have the same basis here with the f. The g doesn't have the same basis as anything, the 3 doesn't have the same basis as anything. So I'm going to get 3 to the third, and then 12 plus negative 8. That's going to be positive 4. And I get g to the negative 9. Okay? Now, again, I told you up here that a lot of times they will expect us to have only positive exponents when we simplify. So let's get rid of this g to the negative 9th. How I do that is 3 to the third. Let's make sure. There's getting to be a lot of writing here. So it's f to the 4th, and then g to the 9th. Okay, so this is our answer right here. And if they want you to simplify, not have like numbers with exponents, you can simplify 27 f to the 4th, g to the 9th. Right? That's up to your teacher. They will decide what skills they're practicing and what they want you to leave it in. But those are some examples that you will work as you continue learning about multiplication properties of exponents.